Hello, and thank you for joining us for this InventX demonstration series here at the Aura Innovation Centre. So today we're going to be talking about 3D printing and computer-aided design. This is just an overview session of our whole May series that's going to be going on, and we're very excited to bring this to you. So yeah, we just want to go over the few Zoom housekeeping. We will be recording this. It will be up live sometime later next week on YouTube, hopefully. Please do mute yourselves and make sure you're muted, but we are actively encouraging you to be involved in chat or Q&A or raise your hand at any point. We will be stopping periodically to check that. So please do get in touch and we will answer them live here. So yeah, without further ado, my name is Dr. Ellis Marshall. I'm the technical manager here at the Aura Innovation Centre. I've been in the whole chemical industry probably 10 years now, and I've recently finished my PhD in 3D and 4D printing. So I'm quite well versed in this 3D printing world. And with us, we have my colleague.
Hi, I'm Jordan Strachan. I'm the CAD technician here at the Aura Innovation Centre. I've had 12 years of CAD experience. I've had some experience with 3D printing as well over the past 8 years. So welcome to the Aura Innovation Centre. We're strategically placed to encourage collaboration across the Humber region. We're located in one of the UK's greenest business parks, previously a brownfield site and bore a pit to extract chalk used in the foundations of the Humber Bridge.
So we want to talk about who we are. Who is Aura? So Aura is the University of Hull. We are part of the university. If you get in touch with Aura, like I say, get in touch with the university. So it's any part, it's the business school. We can get in touch with the Faculty of Science and Engineering. We can get in touch with the Engine Environment Institute. We are the university when you get in touch with Aura. And then the family of Aura, we have the Aura Innovation Centre, which is this lovely building that we're currently in, and we're currently in the digital zone presenting this webinar here. The Aura Innovation Centre is an ERDF funded project along with the University of Hull and East Riding Council. And then we also have the Aura CDT, which is a low carbon, which is a centre for doctoral training focused on wind. So us at the Aura Innovation Centre, what are the benefits to you getting involved here? We're just going to give you a quick run through and then we'll get on to the exciting stuff that you can see behind myself and Jordan, the 3D printing and the CAD. So what are the benefits of the Aura Innovation Centre to you? We can help shape and accelerate low carbon projects. We can access specialist funding and support. We have access to the whole university's research and testing facilities. So again, by coming here, we open the doors to the university. And we can also bring together the skills, knowledge, and share the transfer of information.
So low carbon innovation can happen in any sector. This includes agriculture, using more sustainable pesticides, and also using digital techniques to view both the soil and the harvest. We do also do a lot of research into alternative fuel sources, such as solar panels, hydrogen, and many other different fuel sources. The Aura Innovation Centre is also home to the research into new polymer materials, such as recyclable plastics. We also provide a lot of support to SMEs with waste management and supply chains. So here at InventX, we have these 5 different zones. We have the digital zone, the 3D printing zone, the green energy zone, and also the electronic control system zone where we manufacture printed circuit boards, and of course, the advanced materials zone. So in this series, we're going to discuss these 6 different topics over these 2 different series. And we have, in our 3D printing series, we're going to discuss the different materials that we can print with. So in the first one, we're going to be looking at plastics and the benefits of printing with these plastics, how and why we do this. And also with resin in our second one, which allows for more detailed prints. And of course, the advantages of using 3D printed metal instead of manufacturing these parts using traditional techniques. In my series, we'll be looking at computer-aided design. This includes design for 3D printing, product visualization, and validating design for manufacture. So that's how we produce these CAD models, how we view these CAD models, and how we just ensure that they are right for the clients.
Cool. So we're just going to take a little pause here, and we want to just take a poll and just understand who's actually watching and sort of get a feel of our audience, basically. So we just want to ask you 3 questions. We're just going to pull up the poll. It's as a business, what most interests you in 3D printing? What most interests you? Is it 3D printing? Is it the CAD, or is it both? So if you could just answer that first question. And then the second question, what experience do you have currently with 3D printing? Do you have none? Do you have a little? Do you have a lot? And then what experience do you have with computer-aided design? Again, the same, none, a little, a lot. I just want to get a feel of the audience here and how we can tailor this presentation and the future ones to yourselves. So again, the first one is, as a business, what most interests you? What experience do you have? If you have any, it's absolutely fine to have no experience in 3D printing. That's what we're here for. We are here to educate, as well as get involved with your business and help. So yeah, I think we're getting there. So yeah, it should be quite exciting to go through this webinar series as well. I'm very excited for the 3D printing side, of course. I can't wait for that. So we're just going to get a few answers. A few answers to the poll. So, as a business, what most interests you? Had a few answers. So a lot of people, mainly half of you, have said both. So that's great. So it's great to hear you're here for both of us, which is awesome.
Yeah, definitely.
And then some of you are here for just 3D printing, some are here for just computer design. That's absolutely fine. When we get to the end, we'll share the links for our next webinar series, and you'll have to register for individual ones. So register for ones that interest yourselves. Or all of them. We would love for you to come to all of them. So we have a few experienced 3D printers among us. We have a few dabblers, a littles, and then we have a few beginners. That's absolutely fine. We can go back to the beginning, we can go back to the start and explain the technology more and how to get involved with 3D printing. And then the final one, what experience do you have with CAD? So we've got a lot of beginners and a littles. John is definitely an expert on CAD, so he'll be able to take you through the start to the end. You can see behind him is his rotating CAD design that he's drawn especially for this webinar. So he can take you through that process with his webinar series on computer-aided design.
Yeah, so I'll be going through how I drew this model from scratch, from the idea to the final model. And then throughout the next few episodes, I'll show you how to make that product look visually interesting for clients, but also we can also show how we can give these images to engineers and manufacturers to produce this part in a more substantial way. So that would be very interesting.
So I've just got one question here actually that's just come through on the private messenger. So it's for Jordan. Jordan, what is the most interesting thing you've done on CAD before? What's the most interesting design?
So I've actually designed and built a NHS mannequin with organs in them, and I've had to design the skeletal structure of that, which was quite complex, but it was also very interesting. The organs all fit into this skeletal structure quite nicely and snugly, so that when it comes to actually fabricating this, we know it all fits together in a certain way, and it all looks perfectly fine. Like it was a very interesting job, and I'm happy to have been a part of that. It's definitely very visually interesting.
We'll be able to see more of that in the product visualization, won't we?
You definitely, yes.
We'll see the fantastic renders and all sorts. It'll look wonderful. And you did a lot of 3D printing on that as well, in both plastics and resins. So that'll probably come up in those topics as well.
Definitely, yes. I'll be going through all of that in my product visualization webinar.
Brilliant. So thank you very much for doing the poll. We got some really good answers out of that. Again, feel free to ask any more questions. Feel free to use the chat box. Feel free to get involved. We are here to answer your questions. So yeah, without further ado, I'm just going to go quickly over the different series that I'm going to be hosting. So the 3D printing ones. So first off, we should have. Can I have the first slide? Sorry.
Yes, sorry.
My computer's been a bit slow today. So the first one is just going to be all about plastics. Plastics are very prevalent at the minute. It's a very hot topic. Everyone's all about plastic sustainability. But this first one, like I say, is plastics, but it's about the technology that utilizes plastics, which is called fused deposition modeling, or FDM. It's a very common technique. It's the one that everyone's got in their houses, in their bedrooms if you're a student. A lot of people have it to make the widgets, to make the little bits for the house. But that's not what we're interested in here. We're interested in actually utilizing it for business purposes. There's a wide variety of business purposes you can utilize it for. And I will go through them all in the whole webinar that we'll be doing next week. So you can see this video going on here. Currently, it's actually looking at some recycled material. So this is a recycled plastic. So it's shredded down waste PLA. So PLA is the carbon plastic used in 3D printing. It's called polylactic acid if you're interested. But it's the most common thermoplastic, so it melts when it's heated. And that is my background that we are looking at today. And that is utilizing it. So yeah, back to the recycling. We'll be doing a good chunk of next week's webinar on recycling and how to get involved, the circular economy of plastics, the sustainability, how many times you can use plastics and recycle them before you do need to put them to waste. And the big question is, PLA, is it compostable? It does have credentials to be compostable, but is it really? We'll also be looking at how to utilize it to make door handles and all sorts of innovative things that we've used it for. It's all really quite exciting. I'm quite excited to do it. What else we got? We've got applications and materials. So I've mentioned one material that's called PLA, so polylactic acid. You can also use other materials like PET, which is the common one used for milk bottle tops. You can use flexible materials. You could use materials that might have properties such as they're waterproof. So you need it for a waterproof application. You can use antimicrobial properties as well. So you could use it with copper in there, for instance, which is great for, like I say, the door handles, especially in these COVID times. The door handles themselves will be antimicrobial and antiviral. So here we are again at the filament. So it's shredded the filament into a nice extruded filament, and then we spool it. So I'll be going through loads more on that next week. So the second webinar, which is about the middle of May, we'll be looking at 3D printing with resin. So this is technologies such as SLA, which is stereolithography, or DLP, direct light projection. These are a lot more finer technologies. These have a high resolution and a very high finish product. They can also be good for batch production as well. They've got different materials that you can utilize in there as well. You could use clear materials, so you can actually see your product in action. Maybe it's got a flow of liquid through it. You can actually see that if the material is clear. Like Jordan mentioned with his heart, we've 3D printed a flexible heart, which could be done out of flexible resin. We can also do engineering materials. so tough materials, resistant materials to certain stresses and strains. And we'll also be looking at how to lay the components down in a proper way, in the most efficient way to get the most out of your product. Because if I haven't explained before, I will explain it all in these lectures. But 3D printing is the build-up of layers on top of layers on top of layers. So you will structurally get weak points, and you need to combat that when you build your component. So we'll go way more into detail on that. So yeah, what else are we going to go into? We're going to go into applications as well, materials, how and when to use them, and the benefits to the business. So 2 seconds. So the benefits of resin 3D printing. It uses innovative tech. There's new bits of tech coming out all the time for resin 3D printers. There's a few big brands who very much like iPhones send out new models every year or every 6 months. So the technology is changing rapidly, and it's great to see that, and we need to keep on point with that as well. Like I say, you could do high resolution components, translucent components. We also have done a fair bit of work with medical grade components and medical devices, which is a new field we're looking to help with. Resin 3D printing is great for one-off parts, batch production. 3D printing in general is great for the accelerated design process. So you can take the model one day, tweak it, print it in 6 hours or less, and the same day you could have your updated model, and you could take it to your funder and talk to them about it. But the best bit about working with the Innovation Centre is the access to the academic expertise that we have here at the University of Hull in 3D printing. So not only when you walk through our doors, you also get access to the engineering departments and the medical engineering lecturers and engineering lecturers who are the experts in this field. And finally, based in the Humber, we are right opposite the Humber Bridge here right now. We can see the Humber Bridge from here. It's a lovely sunny day, and we are based very centrally and very locally for everyone to come and get in contact with us. So please do. The final series, which isn't big enough. The final one is going to be metal. Okay, metal. So metal is actually the most interesting one. Many reasons why. This is a component made of stainless steel. You can actually see inside of it, it's actually quite hollow inside. The material is about 50% lighter than a cast one. But with this 3D printing in metal, you can actually make designs which would be impossible to be cast. They would have this lovely intrinsic structure inside, which you just couldn't get with casting. So we have a metal 3D printer here at the Innovation Centre. It can do stainless steel, it can do copper, it can do Inconel, and it can do tooled steel. So it can do a wide variety of materials for you. The applications of this are far and wide. We've seen customers and clients use it on their production line for little widgets that they need printing, or for bits that might need shipping off to different countries. And it costs too much to bring them in now due to the obvious B word. So clients and manufacturers now need to start manufacturing these in-house, these high-spec components out of metal. And you can do that through metal 3D printing, and we'll demonstrate that throughout that webinar. So yeah, we'll talk about the technology briefly in the webinar, the applications, the materials, and then finally, again, how it benefits you. So the metal 3D printing is a strange concept, but it is lightweight by design. You can choose how much material goes in. It's not a solid lump of steel, and it's not a machined block of steel into a component. So you don't get all that waste from the traditional manufacturing techniques. great again for one-off parts or batch production of small components. Again, it's the accelerated design process of 3D printing, which really enables metal 3D printing to come to its own. It's all very exciting. And again, academic expertise, and we're in the Humber. So that is a brief overview of the 3 webinars that I'll be going on. We'll go through this journey, building up our journey and expertise in each sector, and answering a live Q&A. So we have a question. Okay, so we have one question from a chap called Ian. Please tell us about multi-material elastomers for 3D printing. Sure. So we actually have a few ideas on this. Let me just have a think. Yeah, so you can 3D print different materials if that's what you're asking. You can 3D print materials from different sources, or are we talking about recycled materials? So I'll answer both questions. So yes, you can 3D print a lot of materials, and a lot of them don't need to be done on a 3D printer that's at 100 degrees. A lot of them can be done at room temperature. So you can actually print room temperature products, which could be elastomers technically. And you can also generate and formulate your own multi-material here at your Innovation Centre using our shredder and filament extruder, which I think is where we're going with that question. We can do that in-house. We can generate our own material and 3D print it here and take that product into the world. So hopefully that answers your question. If not, give us an email on aic.aura and we'll answer it more there. And then we've got a second question. Where do I start? That is a fabulous question. Yeah, where do you start? Where do you start with 3D printing? Where do you start with CAD? Come to us, come and have a chat with us. Email aic.aura@hull.ac.uk or find us on Twitter. You can find Aura itself on Twitter, or you can come and find myself and have a discussion, and we can get you started on the line. Whether your business is already using 3D printing, or you want to learn more about it, or you want to utilize it straight off. We have a range of clients come in, again, from that experience of CAD to no CAD, to 3D printing and no 3D printing, and they always go away better and more experienced from our consultation. So please get in touch. I'm just going to check the Q&A again. Yeah, so who do you get in touch with? Email aic.aura@hull.ac.uk, and they will pass you on your message, and we'll be in touch very soon to get you started on your process. So that was a question in the chat there. That was a client there has got a project in mind already involving 3D printing and CAD, and they wanted to know who to get in touch. Just email aic.aura@hull.ac.uk. So without further ado, I'll move on to my colleague who will be talking about CAD.
Right, so in the computer-aided design webinar series, we'll be looking at the first webinar will be focused on design for 3D printing. This will include how we can turn an idea into a product that can exist in the physical world. It has to be able to actually exist in the world. With drawings, you can have walls with 0 thicknesses, which physically cannot exist. For our talk, I'll show you how to design a simple 2D sketch, and then transform it into a 3D object through different CAD tools that we use here at the Aura Innovation Centre. I'll then be able to show you in more detail how we can create an assembly with the 3D components to see how a finished project will look when completed, and to also ensure the finished project is 3D printable. So how does this benefit the businesses? There are many benefits of CAD models for businesses. For one, it's a form of rapid prototyping. Using this technical and academic expertise here at the Aura Innovation Centre, we can quickly and efficiently produce working virtual models of your products, which can then be sent to anywhere across the globe instantly. This process is a lot faster to produce than traditional methods, such as producing physical models. These models are also completely 3D, meaning you can rotate them and look at it from every angle to ensure products looks and functions the way it is required to before committing to a final design. You can see all this in this short video that I've got playing in the background. You can see me turning a 2D sketch into a 3D sketch and then rotating it, and also adding other little bits of detail to it, such as this text. So yeah, with this information, we can accelerate design modification by changing parts of the design without having to construct a full new model. Or if necessary, we can start from scratch if the client is not happy with the direction of the project. This is going without risking a large investment for production. The commitment for a CAD model is a lot lower than the commitment for a physical model. With collaboration with the client, we can increase productivity by constantly changing the design of a product to tailor the customer's needs. The process is very rapid, as you will see in the first webinar in our CAD series, where I'll take you through how to design a project from scratch using these CAD tools. So to ensure the quality of our CAD models, we use industry standard software that is recognized by all major companies that are familiar with CAD. Here at the Aura Innovation Center, our clients have access to both technical and academic expertise, including myself. These technicians and academics are on hand to help and advise you with designs and manufacturing, open up a great deal of innovation. We are based in the Humber, and we're happy to help local SMEs, as well as clients from anywhere on the planet. CAD uses virtual platforms to produce models, so our clients can be on the other side of the planet and no travel is necessary, as the final design or product can be sent with a simple email, especially in current times when clients may not want to travel in person. If a person does not have the ability to open the CAD file, we can send it in a variety of formats, including images, which can be viewed by any computer. Like I said earlier, this form of modeling allows for a very low commitment from the client, as we do not have to produce a physical model. And the client does not have to travel anywhere either. So the whole design process can be achieved completely virtually. So yeah, on this video here, I'm showing a few of the different CAD techniques, such as extrusion, and here is mating, and then this is the extrusion here. As you can see, the 2D sketch can turn into 3D, and then I'm extrude cutting this text into this gear, which is what I'll be showing you in more detail in our first webinar. So then moving on to product visualization. So in the second webinar for the CAD series, we'll focus on product visualization and how viewing the product in different ways can help the client, depending on what the drawing needs to achieve. So through this webinar, we'll show you how we produced high resolution, realistic images, engineering drawings, which can be interpreted by manufacturer to produce a product either through one-off, batch, or mass production. And also I was showing you how to display these models in virtual reality. So yeah, as you can see here, I'm rendering the design from the last webinar and also showing how I'd display this so a manufacturer can easily interpret the design. And then finally, this is a VR model that I'll be showing a different VR model for this project. It'll be the same model as here. But here is a good example of what it'll all look like and how you'd select your materials. So right now I'm selecting different plastics, as this will be 3D printed to give it that texture that it'll look like in the final version. So how does this benefit businesses? So ourselves and the client can view an accurate representation of the final product. This is to ensure it is exactly what the client requires, and is also to identify possible problem areas. Again, this will help accelerate the design process, as we can easily identify issues and resolve them. And in turn, this will increase productivity, allowing us to reach a final design a lot more efficiently than traditional methods, and also allowing for more innovative designs. The rendered drawings are a great way to demonstrate the exact look and function of a product, which can be used to both display the product to a client or also use as marketing material. The high resolution images are a great way to visualize the final product, including the finish and texture of it without actually physically building it. This is why it's a great way to help clients understand what the product actually is and how it will function without a large commitment. It's a great tool to actually get across the point of what we're designing. And it's not just this imaginary thing that we've thought up of. All this can be achieved virtually. I can send the files across. These drawings can be viewed in any sort of format. It reduces the need to travel to different places. We can instantly send these files across. So, engineering drawings. They're a straightforward way for a manufacturer to interpret a design. These drawings show the exact dimensions of a part in a clear and understandable way that can quickly and efficiently be interpreted by the manufacturer. This is so they can turn that drawings into a physical product. These products can be anything and made from any material, as the drawings also clearly display what materials and finish each component requires. So for example, I had a client who wanted a design producing to be manufactured with traditional methods, but certain areas of certain surfaces of the parts needed to be welded together. So it needed to have a certain finish to them, certain angles to them, to ensure that those parts, when fully assembled, can actually fit together and be welded together. So yeah, these drawings also ensure the manufacturer that the components do actually fit together, are compatible for the assembly, which makes the whole process a lot easier for everyone. And also reduces the amount of back and forth conversation needed, as all the information that the manufacturer will need will be in these drawings. So we can also, which I guess is what most people are going to be interested for, is the virtual reality. We can also turn our CAD models into objects that can be manipulated in virtual reality. So these virtual reality models are a great way to demonstrate the size of the product, how the final product will function, and how it'll be assembled. It's quite difficult on a 2D screen to interpret size and dimensions. In a virtual environment, you can quite clearly see the scale of the part. You can pick it up in virtual reality. It's just there. It's a great way to get across the size, the scale of the project, and how it's all going to be assembled. As you can see from the short clip at the end, you can remove parts from an assembly, and you can show exactly how those parts go together for that assembly. So for that project, I designed each part separately and then assembled them in a CAD software, and then we viewed them through the VR software to show exactly how it's going to be assembled. So everyone has a good idea of how the project's going to finish at the end and how it all goes together. So yeah, virtual reality, it's a comprehensive understanding of the final product without the commitment of actually producing a physical prototype. So it will help both us, clients, and innovate designs, as it shows exactly how the product can be actually utilized in the real world, as we can put it in these virtual environments. So our clients, again, have access to our academic and technical expertise, which includes ourselves and the staff at the university. These can be used to help advise on certain design choices and manufacturing techniques for these engineering drawings, and also just the rendered drawings, just a good visualization tool. We're located in the region, so we're happy to help turn your ideas into a reality in a low carbon way by reducing the need for travel and physical models. So yeah, these products are all virtual, low commitment again for our clients. They will not have to travel anywhere, like I've said, and can back out or change the direction of the project at any point. They can be easily manipulated because they're not real world objects. They are virtual objects. So at any point, we can change the design, we can modify it to accelerate the design process and make sure that product is ready for manufacture. So in my final webinar, I'll be talking about validating design for manufacture. So what that means is we're going to analyze the model that we have seen, that we have designed, and we're going to make sure that it is fit for purpose. So there are two different techniques we use to analyze these products. One is for safety purposes, and the other is for sustainability purposes. We'll go through how we produce these graphs to show where stress concentrations will occur if a specific product was in use in the real world, as well as displacement plots, which show the amount of deformation in the product that it will undergo during a real world scenario. We'll also confirm if the design can adhere to a specific factor of safety, which we can determine. So, benefits to business again. Computer-aided analysis is a great way to verify a product to ensure it is fit for use. We can very quickly identify problem areas where fractures or catastrophic failure may occur in a system. This will in turn help us accelerate the design process, as it will identify exactly what needs to be modified. Therefore, we're not wasting time changing the whole design. We can just focus on the problem areas where maybe we need to increase the thickness or change the material, maybe add some new supporting parts to the design. So this process can also work in the opposite way. If we've designed a part or someone else has designed a part and they want to make it cheaper, we can look at the areas where stress concentration might occur, or if it's too robust, we can reduce the amount of material or take parts of the design out to make it cheaper, as there's less material, less manufacturing needs, but also make sure it is safe for its intended use by using this determined factor of safety. So with all this information from this analysis, we can increase productivity. We're not wasting time developing areas of the design that are already more satisfactory. We can fully focus on the design of that can be, we can fully focus on the parts of the design that can be innovated further. So something we're very interested in here is sustainability. So we can also do sustainable analysis, which is a great tool that can be used to basically show the entire carbon footprint of components in a system. And we can put all those components together and we can estimate how much carbon these products are producing. So this is every stage of the product life cycle, while also keeping track of the cost for the production of these components as well. So this information is a great way to manipulate the sustainability of a product, allowing us to reduce the carbon footprint as much as possible, while also ensuring the cost of the product is not unreasonably high. So there's some of the factors we take into account then. It's what material is being used, what specific components being manufactured, what manufacturing process is required, where is the product's final destination, and what percentage of waste produced during the product's lifespan will be sent to landfill, incinerated, and recycled. So, as you can see, we get some graphs. These graphs are, and we also get a sustainability report, which I believe is in this short slideshow as well. These graphs show us, and the sustainability report shows the carbon footprint for a single component, the energy consumed needed to make this component, air acidification caused by any step in the component's lifespan, as well as water eutrophication. So using this tool and the data, we can suggest alternative materials with similar properties that will have less of a negative effect on the environment and are more low carbon. Here, this is a great way to reduce carbon while not compromising the integrity of a product. We can also use this data to suggest other manufacturing processes that will be able to fabricate the same part, but are more low carbon. So as we change all of these variables, we can compare the results with the previous version to determine if the product is more sustainable, while keeping a close eye on the cost. So yeah, both of these tools are great ways for material validation, as we can confirm that a specific material is both strong enough for a certain purpose, while also increasing sustainability. Both of these tools work hand in hand to achieve a low carbon product that is guaranteed to be satisfactory to a certain factor of safety over a determined period of time. You'll have access to both academic and technical expertise, like you do with every other aspect here at the Aura Innovation Center, which includes us and the staff at the university. They can help assess the designs to determine if it's fit for use and to show how sustainable your whole product will be. So again, this is all virtual. So there's low commitment, low investment. It's all done through computers and analysis. And again, we're based in Humber, which is a prime position to help local SMEs, but also companies that are further afield due to the ability that we can work in a virtual environment. So the results from these analyses can be sent to clients instantly to guarantee them the design is more than adequate for the intended purpose of the final product. So do we have any questions?
Yeah, so there's one question that I want to ask you, Jordan, which has come from Anonymous. So they've got a product design in mind, but they're not sure what material to use to ensure durability. How would you test this?
Well, we'd start with whatever basic, but we'll look at the design first, see what material sort of looks like it'll be right, and we'll put that through some computer-aided analysis software. We will then find materials with similar properties and sort of compare the results in both, like I said, sustainable purposes and also to see if the displacement is greater or less than, to see if it is satisfactory to adhere to that factor of safety that we have determined. So the factor of safety, I'm not sure what the actual value is for certain products, but it's a standard term that's used to ensure that a product is safe to be used. So for example, you don't want an airplane breaking, for example. We use factor of safety to determine that each component in that airplane is satisfactory.
So you can test all of the parameters basically on computer-aided analysis, which is awesome.
Absolutely, yes.
So we've got one question as well, another question.
Okay.
With metal 3D printing, what is the accuracy? I think I know the answer to this one. So the accuracy on the metal 3D printing is 25 microns or 150 micron, depending on the features, whether it's a hole, whether it's a slant, whatever. It will range from 25 to 150. But the nozzles, the actual resolution of the nozzles that can be printed, I shall pass on to Jordan.
So, sorry, what was the question again?
Accuracy of metal 3D printing.
So yes, we have two different nozzles that we use for the InventX. We have a standard nozzle that can print a lot faster, and we have another nozzle which is used for very fine details. We can swap out these nozzles quite quickly to design to print more metal parts that have a more detailed structure. So recently we printed out some small clamps, which were used for a very tiny sensor in metal, and we tried them in both the high-res nozzle and the regular nozzle, and we found that the high-res nozzle obviously did a lot better job than the regular nozzle. So that we have those two options. So if I remember rightly, it is.
They can get more information as well, John. We are running out of time.
Okay.
So if you want more information, you can contact us at aic.aura, and we will gladly sit down for an hour or more and chat to you about the resolution of metal 3D printing. We can take you through the process and the software that we use as well. And the software is always getting updated from that manufacturer as well to look at these tolerances. So we'll just take you through the next few slides we've just got to finish us off. So we just want to tell you what is next in the future. So we have my 3D printing coming up 11th of May, 18th and 25th, where we'll be looking at the plastics, the FDM technology, the resin with SLA technology, and the metal. And I'm very much excited for that metal one to show off the copper, the stainless steel, the Inconel, whatever we can do. And then we have the computer-aided design webinars from Jordan on the 13th, 20th and 27th of May, looking at all these parameters that he's gone through. Yes. And I'm very excited for all of them because I learn so much from him every time he talks. It's fabulous. And then in the future as well, we have in June, we have an advanced materials testing webinar. And in July, we have electronic control systems or printed circuit board prototyping, and that'll be in July. And then September, we have the augmented reality and virtual reality webinars. So yeah, that's a quick overview. You will have to register for each one again. And do we have time for a little poll? Yeah, so we're just going to put a little poll up. Which of our future sessions do you plan on joining? And so I've just run through the list. So we've got the 3D printing side, we've got the CAD side. Please tick one and let us know which one you've come into, or tick them all if you can. And yeah, so it's really exciting to do the advanced materials one. That'll be coming up. That'll be looking at selection of materials, how to analyze materials, analysis, loads of different factors coming in there, flows of materials, melt flow. There'll be lots going on there. The printed circuit board is taking a printed circuit board, a concept. You want a circuit board for this application, for that application, and taking you through the process of how we deal with it here using our technology here at the AIC and the academic expertise at the university. And then in September, we'll be getting onto the AR/VR headsets, and we might be doing a few interactive things. So if you have a headset, you could probably join us on that. But if you don't, that's absolutely fine. And you can see the technology that we're utilizing and how it can be utilized. Jordan has already talked about how we utilize VR for CAD, which is very, very helpful. So yeah, it's very exciting. Do we have any answers? Woo, loads of people. That's brilliant. So yeah, we've got the 3D printing with plastics. I think everyone's coming to everything. So I'm more than happy there.
Yeah, definitely. No, it'll definitely be interesting to see.
Fab. So if we just move on to our last slide. I just want to thank all of the staff who helped put us on. So we've got Joe and Roz. They are fabulous people who helped put us on. And then we want to thank you, the audience.
Yes, thank you for joining us today. It's been a very interesting experience.
And thanks from myself and Jordan. Thanks for joining us, and we hope to see you soon. For more information, please go to our website or follow us on Twitter. See you soon.
Bye.